Taking the cue from genes, human networks, and telecommunication networks, the DIME computing model exploits the parallelism and signaling abstractions to implement fault configuration, accounting, performance, and security (FCAPS) management of a business workflow executed by a network of von Neumann stored program computing nodes. A DIME is a managed Turing machine with an overlay of a parallel signaling network that allows dynamic control of the computing nodes. A service implemented in a DIME component consists of two parts: the service regulator, denoted by SR, and the service execution package, denoted by SP. The regulator is like a control gene and sets up the service package before it is implemented. The service package is analogous to a chromosome that contains a workflow execution package, and here we show a very simple service that is being executed. It is controlled by the signaling channel through stop and start commands, for example. It can also redirect the input and output of the von Neumann computing element. A parallel signaling network overlay allows using a network of DIMEs to be programmed to execute a managed workflow. The DIME computing model supports the 4 genetic transactions of replication, repair, recombination, and reconfiguration. Here we see replication in step 1 by loading and executing the same service package in a new DIME. The replication is exhausted, of course, when resources are no longer available to complete replication. Each DIME can be dynamically controlled using the signaling channel. Step 2 to 6 show how the service workflows can be reconfigured. Here we are executing a new package S2, which executes hello world as a service. The parallel FCAPS monitoring and signaling controls are used here to implement a self-repair of a service workflow. The two DIMEs, DIME 2 and DIME 3, are instantiated by DIME 1, which controls the repair workflow. The heartbeats and the performance monitoring data and the security are all implemented in parallel. When DIME 2 heartbeat is not detected by DIME 1, it immediately executes a repair workflow which reinstantiates a new S1 and restarts the service that was broken. this slide, we show how two services can be combined with another DIME into a new service. We are showing here two DIMEs essentially storing records based on their color attributes. DIME 1 and DIME 2 are reading records and storing them with certain color attributes. Now, we will combine these two DIMEs along with another DIME in a network to convert this into a sorting service. As you can see, the blues are now in DIME 1 and the reds are stored in DIME 2. This is done by essentially redirecting the control commands to change the implementation of the services executed by DIME 1 and DIME 2. We conclude this presentation by saying that the key to the telecom grade infrastructure is using the genetic transactions provided by the DIME network computing model.
Ce soir le vent